Hello, my name is Arnd van der Weijden. I'm heading the wireless audio and voice business unit within Dialog Semiconductor. As Dialog Semiconductor, we make chips for voice terminals, for ULE devices, and also for audio, headphones and headsets and microphones. Let me explain a little bit about our products and the end products which our chips go into. First is the voice terminals. As Dialog Semiconductor, we have a long-term experience in these kind of applications. Our excellence is in the high HD voice and making the complete systems. What you find is our chips are nowadays used by all the A brands, and you'll find them in products from Panasonic, Gigaset, Deutsche Telekom, but also gateway suppliers as AVM. The beauty of the total solution we offer as Dialog Semiconductor is not only the chips in the terminals for voice itself, but also the chips which go in the gateways. This allows the opportunity to make complete solutions, home networks for voice, but also adding extra functionality like ultra-low energy sensor devices. Next, as a second step, a second kind of products as Dialog Semiconductor, we offer chips also for ultra-low energy applications. So here we expand the home network on 1.9 gigahertz frequency to a new application area. What we have done from a semiconductor perspective is make chips which are really low power in its application, and so that we can, instead of just standard voice terminals for making phone calls, also have new applications. Some of the examples we see here are from brands like Gigaset or AVM or Eurotronics or ECT. These are products which are made for in the home. We have sensors for area control, we have door sensors, window sensors, and what we can do with this is making in the 1.9 gigahertz a network which is interference free, where both voice and data can be combined. One of the advantages of this is that we can not only have sensors for passive control, but also like a product this for radiator heating, where it is an active control, so that on each radiator on your house you can have such a thermostat knob and control the temperature in your room. And that can be all done with one and the same radio technology. One of the big advantages of using DECT on 1.9 gigahertz frequency spectrum is that we can not only do data for ultra-low energy, but also can combine it with voice. A good application on this is a pendant. A pendant is something which can be used for elderly or other purposes. It's not only a panic button, but it's also something with a speaker inside, a microphone, so if people have an accident in the house, that immediately a contact can be made, and it's all connected to a gateway, and that can be done to a service or a cloud service which is behind it. As Dialog, what we are aiming at is we make the chip and the solution, system solution which we can provide, so that sensors and products like a pendant can be enabled with. And what we take care of the chips is that they are small in size, that we can use small batteries, so that attractive sensors and actuators can be made of it. And that all can be done combined with voice terminals in a complete home network. As Dialog Semiconductor, we take the 1.9 gigahertz wireless solution, which we used in the home for voice communication or for ultra-low energy sensor communication, one step further. The same radio spectrum and technology we can use also for attractive new products. And what we've done is we moved into three new areas. One is unified communication, products which are hooked up with Microsoft Link application software, and that's actually the terminal where you make your phone call is the PC, and that we can have our chips in attractive headsets which are perfect in audio quality, and both in the microphone and in the speaker size. It can be on the ear, over the ear. There are various flavors of headsets, and the trick is what we do is to make our solution such that we can work with small batteries and have best HD voice audio quality, and also that we have a good DSP capabilities in there to run all the necessary algorithms. Next to unified communication in cordless, we also look at solutions for headphones, headsets, corded, and in that area we make also a range of chips which fit into products like these, where we have headphone headset combination, full stereo, full hi-fi with microphone, and also with easy buttons if you want to make phone calls or connect it to application software like the Link software from Microsoft or Cisco Jabber. Okay, as Dialog, we take the possibility here with the new products to improve further on the audio quality, and we do that by taking more advanced DSP algorithms into our chips, make sure that also the DSP power is improved, and also we take special care with very low power codecs with very high performance, so that the user perception and the experience of headphones and headsets is to the maximum. Next to this segment of headphones and headsets, we moved also a third area, and that is to microphones. Microphones take advantage of 1.9 gigahertz wireless solutions for two reasons. One, 1.9 gigahertz is an interference-free band, which is a big advantage in this audio space. The other thing is that with the protocol we use, we have low latency. And especially with microphone applications, it is very important that if you talk or sing or do other things, that it's what we call lip sync. So there's a very low latency between the microphone, the wireless connection, and the base station unit. Our chips, we have made them such that together with the firmware we include with it, that it can be used as a platform. It can be used in high-end microphones, like in the semi-professional area, where low latency is extremely important. But also we have, for instance, the more consumer-style microphones, which can be used in karaoke games or other kind of applications. The beauty of our concept of the chips and the solutions we provide is that they can be easily be used in the various applications. And due to the platform concept is that there is a high level of reuse of IP. So that's algorithms which have been developed for one type of product, if it's a headset or it's a microphone or a combination of the two, that they can be reused in the new products as well.